Let's examine how individual atoms are organized in the structure of pure silicon material. This simplified diagram of the atomic arrangement of pure silicon material, called a crystal, shows that the valence electrons are specially situated. The atoms are bound together by sharing their 4 valence electrons with 4 neighboring atoms. This type of arrangement is called a covalent bond. The net result is that each atom has 8 valence electrons. This balanced valence band makes pure silicon crystal appear like an insulator. No loosely bound electrons are available for conduction, yet the bonding is not as tight as in the case of insulators. Although pure silicon crystal appears like an insulator, it can still conduct a very small amount of current easier than insulators can. This is because as temperature increases, the force of heat energy dislodges a few valence electrons from the covalent bond so that they become free electrons. When a valence electron is freed, a vacancy, called a hole, is left in the valence bond. Heat energy is commonly referred to as thermal energy. The holes and free electrons produced by the thermal energy at room temperature are almost insignificant in number and are called minority current carriers. This is in contrast to more abundant majority current carriers that are produced by a more desirable process called doping. We shall discuss doping in the next segment. Before a few more questions, let's summarize the main points we presented in this segment. In atoms, the outermost band of electrons is called the valence band. Conductor atoms generally contain 1 or 2 valence electrons. Insulator atoms usually have close to the maximum number of valence electrons, 8. Semiconductor atoms most commonly contain 4 valence electrons. Semiconductors fall in between conductors and insulators in their ability to conduct current. In pure silicon material, atoms share their valence electrons in a covalent bond arrangement so that each atom appears to have 8 valence electrons like an insulator. Pure silicon can conduct a tiny amount of current because heat energy, commonly called thermal energy, produces free electrons. That is, valence electrons dislodged from the covalent bond, and holes, or vacancies left by the freed electrons. Free electrons and holes produced by thermal energy are called minority current carriers.